Hi students, welcome to Year 11 Chemistry and the first module, Properties and Structures of Matter. This is the second video in the series on separation techniques, and it's all part of the Chemistry 300 series. In this video, we're going to start looking at some of the important separation methods that you will need to know. Previous video, we looked at the fact that there are different types of mixtures, which might include emulsions, colloids, solutions, and suspensions. Now, the important thing is that you match the separation method to the physical properties that are relevant. So if we have a look at a couple of these examples that I've identified for you here. So this is filtration. This is one example of a separation method I'm sure you're familiar with. This happens when we have a material, a solid perhaps in this case, that will not dissolve in water. What it does is that it has a higher particle size. It's insoluble in water, and as a result of this large particle size, the large particles will be caught in the filter paper, but the water will pass through. Being a smaller size, it will pass through and collect in the filtrate at the bottom, and will be left with a residue at the top. Incidentally, I've picked this particular diagram because the way that this process is being demonstrated also looks like another separation method known as decanting, where if you're careful you can actually pour the liquid off the top of the sediment at the bottom. Over here we have centrifuging, and a centrifuge is used again based on differences in particle size. And this uses the property of gravity. So as it spins, we get the most massive particles, which will sit on the bottom here. And blood is one good example of a substance which is separated using a centrifuge. One of the ones that we'll be looking at as part of the next video in terms of the gravimetric analysis is evaporation. Now, the problem with evaporation is that it usually involves a soluble solid dissolved in a liquid. And so in this case, we have to rely on a couple of things. The main thing we're relying on here is different boiling points. Differences in the boiling point are what is going to be critical here. So as we heat the water will reach its boiling point, it will boil, and the water will be released from this particular mixture, and it will leave the residue again sitting behind in our evaporating basin. To look at an example in a little bit more detail, this example is distillation. It relies on the fact that, again, there are differences in boiling point between components of the mixture. Usually this happens for miscible liquids, which just means that they will mix with water. So we rely on the fact that there's a difference in the boiling point, and often what we will do is use something like ethanol in water, or here you can see we've got salt water. The difference between this one and the evaporation, of course, is that we don't lose the substance which boils first. So it will turn into a vapor, it will rise up, but as it moves back through the condenser, it will condense back into a liquid and drip here. So the advantage of this method is we actually get to keep both of the components of the mixture separated from one another. We're going to have a look at some examples of these in the classroom. Thanks for watching.